Hello and welcome to Martin Maths. We're doing a higher GCSE maths paper and we're going to go through this question on data. And we have a table showing the information about scores in a test. The least mark was 77, median is 82, low quartile is 80, interquartile range is 4 and the total range is 10. And we're going to draw a box plot. So to draw a box plot, we need to have a mark for each of these main points. 77 being the least mark, so I'll draw a line there. That's 75 and it's, so it's going 76, 77, 78, 79, 80. So my mistake there. Draw a line there. Okay, so you can ignore that one. The median is at 82, so that's 81, 82 there, that's 82, that's the median. The lower quartile is at 80, and we'll turn this into a box shortly. So now, I know the interquartile range is 4, so interquartile range is the upper quartile minus the lower quartile. So that's the lower quartile there. So I've used those two pieces. I've actually used those three pieces of information. Interquartile range is 4, which takes me to 84. There's 82, 83, 84. So I'm going to put that's where you make the box. Okay, so you've got upper quartile, median, lower quartile in that box there. And that's the 84 there. Okay, so 82, 80 with that range of 4. That gives me that box. Then I have a whisker down to the least mark. Now they tell us that the range is 10, so I know the biggest mark is least mark plus 10, so 87. So there's 85, 86, 87, and I'll do a whisker up there. So it's a box and whisker plot there. And you can see they've drawn another one with some other data from Group B. It looks similar in respect of having a box with a median in the middle and whiskers to the side. So again, just to go through that, least mark of 77 there, low quartile of 80, median of 82, interquartile range of 4, so that's there. That distance there is 4. They haven't given us the upper quartile, but I can calculate the upper quartile being 84. And then the range, the highest mark being 87. Okay. So that should give us 3 marks there. Then they give us this other data set, Group B, and we have to compare the distribution of marks by students in Group A with those in Group B. So the main things you've got to talk about here are where the medians lie. So the median in A is higher, okay, so where your middle term is, and where your middle 50% is, your interquartile range. Is it all neatly packed or is it quite spread out? And the interquartile range, so the middle 50% is bigger in B, so a higher spread. And you can see that that box, that middle 50% is quite spread out compared to that. Okay, and that gives us a total of 5 marks for that in question 10. I'm going to jump now to question 17 in this paper, where there are 2 right angles. All the measurements are given in centimeters, with A minus 1, B minus 1, and C minus 1. That's the hypotenuse, because there's a right angle. It tells us there it's a right angle, so you know that's 90 degrees. And we have A, B, and C. And we have to do a show that. I love a show that question because we know that if we get that, we've got the answer right. It's a 3-mark question, and that's what we're aiming for. I'm going to start with Pythagoras. And by Pythagoras, I know that C minus 1 squared equals A minus 1 squared plus B minus 1 squared in this triangle. Similarly, know that it means the same thing here. It's a little bit easier. Sum of the other side squared equals the hypotenuse squared. Okay, so that's Pythagoras' theorem. I'm going to expand these. C squared minus 2c plus 1 equals If you want to see it in full, a minus 1 plus b minus 1, b minus 1. So I'm going to get a squared minus 2a plus 1 plus b squared minus b minus 2b plus 1. And I could have done that same there. Okay. Now, I'm going to see if I can do any simplifying. I see that I've got a c squared, an a squared, and a b squared, and I have that here as well. So I'm going to replace that with a squared plus b squared. Okay, from here. Equal to a squared minus 2a plus 1 plus b squared minus 2b plus 1. But now let's do that simplifying. I've got a 1 and a 1 there, they can cancel. I've got an a squared and an a squared, b squared and b squared. I'm just, I've subtracted a squared on both sides, I've subtracted b squared on both sides. Minus 2c equal to minus 2a minus 2b plus 1. So I've simplified it, and you can see I'm nearly there. Keep that in mind. There's no squared terms there. I've got rid of all the squared terms. There's 1. I've cleaned up 2 of them. So now I'm going to bring those two to the side. 2a plus 2b minus 2c equals 1. And I think that's exactly what I was required to do. 2a plus 2b minus 2c equals 1, as required. Okay, a nice 3-mark question there, all based on our understanding of Pythagoras. One last question for this video. Some surds. So 2 root 5 squared, which is 2 root 5 times 2 root 5, which is 2 times root 5 times 2 times root 5. You might be able to do this quicker, but I just want to show it explicitly. 2 times 2 is 4. Root 5 times root 5 is 5. So it's 20. It's just 1 mark. I could have gone straight there. Okay? 4 times 5. Now we have to show that 2 terms, 2 brackets involving surds can be in the form a plus b root 7. So let's expand it. 1 times 3 is 3. 1 times 2 root 7 is 2 root 7. Minus 3 root 7 minus root 7 times 2 root 7. Okay, so I've expanded those brackets. Let's clean it up a bit. 3 plus 2 root 7 minus 3 root 7. Collecting those almost like terms as though they were, if you imagine a's, when you're expanding brackets in algebra. Minus root 7. Now here, root 7 times root 7 is 7. So it's going to be minus 14. So I'm going to have 3 minus 4, minus 11 minus root 7. And there I get a and b are integers. So a is minus 11 and b is minus 1. Okay, so nice 2-mark question there. One more on surds. 1 over 4 minus root 11. We have to rationalize the denominator. I'm going to multiply by something where the numerator and denominator are the same, so it's multiplying by 1. I'm going to multiply by the same term, but just with a different sign. 4 plus root 11, and we'll see why this works. So in the numerator, I get 4 plus root 11, but in the denominator, 4 minus root 11, 4 plus root 11. It's like a difference of 2 squares. I'm going to get the surd terms to fall away. 4 plus root 11, I get 16. Then I'm going to have minus 4 root 11 plus 4 root 11. Minus 4 root 11 plus 4 root 11 is going to equal 0. So I don't need to do those middle two terms. Minus root 11 times root 11 is going to be 11. So I end up with 4 plus root 11 over 5. So my denominator is rational, and that's what that asks us to do. Okay, that's a nice 5-mark question there. So we've done some surds, we've done some Pythagoras, and we've done some box plots. Thanks for watching. Don't forget to like, subscribe, and share, and good luck for your exams.